So in 3, 2, 1, just tell me. Oh. Hi, good afternoon, good morning. Welcome to our new version of Digital Futures in International. I'm Alberto Fernandez, and I'm going to be your host today. Yeah. Today, what we have is in our agenda. Sorry, I need to cancel the share screen. Hi, good morning. Yeah, there. So what we have today is the BIODIG conference about what happened a few months ago in the Triennial Global Symposium on Biodigital Architecture and Genetics. This was a principal platform for interaction, interdisciplinary and interorganizational dialogue on topics connected to biodigital architecture and design, bringing together attendees from around the world who are deeply involved in creating innovative, natural and computational strategies to address social challenges and changes. In this session, we will be discussing the most representative outcomes from presenters that are opening the research agenda in this particular field. Today, our guests are going to be Alberto Estevez, Jobna Abdallah, Angad Warang, Efimia Yiannopoulos, and Pablo Vaquero, Lamila Simisic, Marcelo Fraile, and David Torreblanca. Please, I'm going to start with our first presenter. So, Alberto, be welcome to turn on your camera, please. Because we want to start with the introduction about this. Firstly, I want to mention who is Alberto Estevez. Well, he has been really well renowned during the several decades till now. Alberto Estevez is an architect with a professional office of architecture and design in Barcelona since 1983. Chairman, professor, founder, and first director of SARC, the School of Architecture of UIC Barcelona, founder and first director of UIC Architecture PhD and Masters, director of IBAG UIC Barcelona, Institute of Biodigital Architecture and Genetics, which includes the Genetic Architecture Research Group and Office, and the master degree in Biodigital Architecture. He has written more than 200 publications, participating in a large number of exhibitions and invited lectures around the globe, presenting ideas, projects, and for sure works. Well, Alberto, just feel free to start this round of presentations with the introduction of what happened a few months ago with this conference, which was really fascinating.
Okay, thank you, Alberto. Thank you, Digital Futures, for this invitation. That will be great to share with you all the presenters today. First, Jobna Abdallah, that will present also something that we are doing together. And after also Angad Warang, that is also all of the presenters of today are teaching in the Master of Biodigital Architecture and are in the group or research group of Genetic Architectures, etc. So we know each other very well. And yes, we are all of them are related with the biodigital architecture, design, teaching, work, research, etc. And if you want, I will share now the presentation that have to do, yes, what we was doing some weeks ago. And let me check to do the whole, well, it's not possible. I see that now is not working. Why I cannot put
in
here? Yes, now yes. Okay, so yeah, we was doing this conference, participating all of us in the conference, and because the idea was to take from the okay, now it's not working the way to, okay. The idea was that 25 years ago, in 98, when I was director of the school, we was inviting all these pioneers of architecture, digital architecture, and all these pioneers, Cartoon, Leach, François Roche, Carlos, etc. I wanted to invite them again after 25 years. So they was sharing in a round table again together as it was 25 years ago, but also opening the idea of as it was in this historical photo of special personalities that was together at the same moment in one time. I wanted to do the same with all these pioneers of digital architecture. Yeah, that is this case. Also open to now the new generations. First, the guys that are now also in the front line of biodigital architecture, and also in this photo, all the contributors and presenters and etc. that we was all together, and here also the organization team for this conference. So the point is that this is working very bad. Okay. The key idea that is behind our biodigital architecture research and teaching and work and projects and designs is this similarity that exists between biology and between digital. So we are working in this line, the fusion between biology and digital, and the powerful possibilities of nature and of digital technologies. We're working in this line. So understanding that when in 20th century they was designing from the spoon to the city to do the design for modern world, we now in 21st century are allowed to work from DNA to the whole planet. So this is what we are doing from the research group, from the teaching, from the office of designing also objects and furniture, and from the working with DNA and bone cells and bacteria until bricks and objects and furniture and housing and schools, etc. And also here some example of the master workshops that we are doing from 23 years ago, and the publications that we are doing, and some, well, what is behind all this? I go very fast because the time is gone. Behind of this is our reality, and this reality is in all the planet. And so what we see is that life at the end is what the most efficient way to change this reality and to help to the sustainability of the planet. So in this way, we was going deeper, more deeper than only the surface of the things, working with DNA and working, again, this is really a bad way to move. I don't know why it's not working. Sorry. Now, yeah, the working with genetics. So we was researching the bioluminescence in different ways. With first the GFP gene, after bacteria, after the genes of bacteria in ornamental plants, after also using bioprinters for work with bone cells or algae or all these. Understanding that we are going in a very multi-scalar and multidisciplinary way to work. For example, also with bricks or with, again, is not working really well. Okay, so, I go fast. Is something that you can see in our publications, in our websites, in our conferences and books. So I go fast to see also this last foretour that I was also doing with Pablo, with Femi, and with Yomna, also this family of foretours and all these seeds. As you see, everything is related to the research with biology, in this case with the microscope, electron microscope, searching the structures of nature and applying this learning from nature, from biology to housings, to schools, to every competition that we go. In this case, this is a university building, a market, and another market here, also an antenna, understanding that we need to activate sustainability in everything that we do. And this is why here, for example, we try to create some towers that includes the 17 United Nations goals for sustainability. And this is also what we are researching, what we are designing, what we are teaching in the master too. To include all this understanding and learning from the advantages that biology teach us through the digital tools to until it's not working. This makes me really crazy. Sorry, but now, so yeah, to designing from cities to the whole planet, as you know, that our planet now is in need of a holistic design, of understanding that everything that we are acting in every corner of the planet affects the whole planet, as we was experiencing in the COVID pandemic. And that we are acting, for example, with this urban action or other urban action to explain to the people that we need to take care of nature, that also nature maybe are watching us, and that we need to have some responsibility, personal responsibility for every little thing that we are doing in this world. Okay, thank you very much. And I will give the word to the next, Yomna, Angad, etc., for following this nice talk. Thank you.
Yeah, thank you, Alberto. Well, I'm going to introduce now Yomna, Dr. Yomna, as next presenter, as you already mentioned. Yeah. Dr. Yomna Abla, IBAG, Institute of Biodigital Architecture and Genetics, and the Genetics Architecture Office at Universitat Internacional de Catalunya, Barcelona. Accredited assistant professor leading the research line in biointegrated systems and biomaterials at IBAG for synthesizing bioactive systems and materials to achieve sustainability. She has been in academia teaching and research on an international scale for the last 10 years, specializing in particular in biodigital architecture, microbiology, and bioengineering, with several publications in highly ranked index journal and editorials. She's going to present us a project that addresses the intersection between bioinformatics from advanced bioimaging tools and techniques and AI computational neural networks in designing optimized minimal rule surfaces for multi-scale biomorphic design applications. The screen is all yours, Yomna, and please enjoy the presentation.
Okay, thank you so much. First of all, I would like to thank Professor Estevez for always including me in his very creative and cutting-edge projects. I am also very happy to reunion again with my colleagues and friends, Angad, Femi, Pablo, Lamila, Marcelo, everyone. And thank you so much also, Alberto, for organizing this event and Digital Futures. So as he was presenting, the topic that I will speak about is the hot topic of the hour, AI integration in design and in architecture between so many conflicts and topics that we can like debate on or discuss for hours, but I will try to do this in a quick way. So what we have presented in the BIODIG 2023, the conference, that the topic of how to achieve multi-scale and multi-application biomorphic AI-aided design from a biomaterial point of view, or specifically for the intersection between bioengineering and biomaterials development and design and architecture, and how AI can help in this. First of all, I would like to start with this quote of AI is not coming for us all, and sometimes we need to look deeper into how this meaning, not from a egoistic point of view. So if we are using AI for a good objective, for within a good criteria and a good framework to reach to something further than just experimentation with the tool in itself, or for just generating visually appealing results, this is what we consider, or me and Professor Estevez, that we consider as a good, or the use of AI that we aim to achieve. So in our research, we aim to use AI image generation as part of this process, complex process of biomaterials research-based design, which is already very intricate and interdisciplinary. The keywords or the key objectives are sustainability, functionality, durability, and also engineered living materials that are providing something more, a further sustainable function, or a further sustainable operation that they can add to the built environment. For example, biocatalysis, bioelectricity, bioremediation, biomineralization. All these aspects are part of already our biomaterials research-based design in the EBAG with Professor Estevez. So, and the criteria we or the workflow method as a materials and methods approach, we are more focused on experimenting not just with the tool, but what is behind the tool. So if this means that we as designers and bioengineers are obligated to search behind the tool, to search in the scripting and programming about on these tools, for example, diffusion models or convolution, all these we have to not be afraid to conquer as well. So, for example, our first approach on this was to use all, or like approximately all the scanning electron microscopy images from the library of Professor Estevez, which is very rich library of more than 1,000 images, and how to use them all as a training data for GANs to develop a new design, or to develop a biomorphic shifting aspect of these images. And as you can see here, that this was not the training model, or the model of GANs, the AI model of GANs was not very creative in producing something new. It was only fluctuating between these images or structures of data without providing or without offering something new that can be considered as a design in its own self, an independent use, an independent function, or identifies as a design. So we move to the next step of considering these tools, the new emerging tools of diffusion models, as rendering tools. And we were developing this kind of research study from a designer point of view, how we can integrate these tools into the design process in a tangible way, in a useful way. And we compared through two case studies of designs, as you can see here, and as it's published in our paper, the biomaterials research driven design visualization by AI text prompt generated images. You can see here that we compared by the design that we developed by ourselves in normal digital design tools as Rhino, Grasshopper, using biomathematical models of reaction diffusion, of the differential growth. And we compared this with the prompts that we use to generate images from the same topic based on biomaterials, as using bone cells, as using seashell and eggshell biocomposite materials. And in the end, we found that it stopped at a specific level that it couldn't pass through to come to the level of real fabrication of these models, of these images, because of the problem of 2D to 3D interpretation. And also arises many questions of data validity, of copyright, of authorship, that are, of course, very big topics. And I will try to go more quicker to let also opportunities for the others. And then we from this topic, or from this comparison in the design process, we come to experiment more on other biomaterials research that we were performing, and this is what we exhibited in our lately published book, AI to Matter Reality, where we experimented using the diffusion models in many other this is not working. Yes, it is. In many other topics. Yes, I will go very quickly. I only
No, it's not that, Yona. Can you put it on full screen? Some of your text is very I can't see the detail. So can you please put it on full screen, please?
Sorry, but I think if I put it in full screen, it will go very much slower. And maybe I don't know. I will try, but I think it might.
Oh, no worries.
More time.
So I apologize. Just wanted everyone to see how your beautiful images and text. My apologies.
Thank you so much. It's now in full screen. Everybody can see?
Yes.
Yes, it's beautiful. Thank you.
Okay, thank you so much. So within the book, for example, one of our biomaterials research was bioplastic, how to develop bioplastic in relevance to also a bioreference, for example, dragonflies that are transparent and very lightweight, similar characteristics with the material of bioplastic. Also the orchids and their color degradation, their transparency. And so we find always a relation between the bioreference and the biomaterial. And in this case, AI was very successful in generating many, if you want to say, phenotype expressions of the genetic word or genetic text expression that we feed to the diffusion model. And later on in this book, we have also developed a classification model, a clustering model, in order to organize the results, how to choose and how to make a criteria for the relation of genotype, phenotype, and how it was presented. So you can see also here that another biomaterials research was a starch-based non-Newtonian materials, which we are now developing further with our PhD student and Nadim Tariq. And we see also how to relate this with the same bioreference here, for example, was the starfish, the sea fish, and for example, also other things that are very creative because it's a non-Newtonian material, so sound as outlandish or alien. And this is why also we were experimenting with. All these are related really to research of temperature effect with climatic effect and all this. Also pearls developed from seashell, eggshell-based composites, bio-inclusive design, as including bioreactors, or for example, including bacteria, bioluminescent algae. All these were very successful experience that we include in a book of 10 chapters. Each chapter is about a specific biomaterial, is about a specific clustering model that we use to generate this classification of genetics and the phenotypes that are generated from it. However, we reached to a point, and of course also the engineered living materials of bone cells, of T cells that are defender cells for the human system, how to use this really in something that can be also integrated in the built environment. So after it's all 2D, it's all static in a way. And what about if we can use this unlimited ability of AI models to generate very much data, new data, if you want to say, and to see how we can include this in something that is more dynamic, more productive of new data. And we reach to use the convolution neural network as the base of this transition of keyframes, because we also see that this is the only more possible way to translate 2D generated, AI generated or design or pictures or any 2D information to 3D in a reasonable way, not just as an extrusion of the information of a 2D data structure or a simple interpretation, but more as a prediction of the third dimension around 360 degrees around the model itself. So we found that convolution is our way, and we are now developing this through multi-scale, multi-application, and biomorphic design for also engineered living materials, more specifically in the case of bone cells and T cells. And we see that also arranging these keyframes and analyzing them, each of them return us again to the biomathematical models already that were the starting points before the AI models emerged, as reaction diffusion, differential growth, all these biomathematical models. And then, as you can see here, for example, this is one case of a bio-inclusive design of a house or a tower. And you can see that each of the frames that you can see here, the transition between the frames, 10 frames, 5 frames, each of the frames that we have in itself offers a design of something, an interior design or attention structure design. And if you analyze it more, you'll find, for example, a biomathematical model of Voronoi or of hyperbolic paraboloid surfaces or tensile structures. And also, we repeated this for very, like more than 100 videos. I think that we exhibited some of them also in the conference, BIODIG 2023. And as you can see here, also integrating some words as Gaudi, for example, and it gives us new eye to imagine the works of Gaudi in relation to biomaterial. And it continues, for example, in bones. You can see Voronoi, reaction diffusion. And this is my last slide. Thank you so much for the invitation. And okay, I let now to the following is Angad. Thank you so much.
Thank you, Jomna, for your presentation. Okay, as she mentioned, the next one is Dr. Angad Warang. My friend, I'm going to introduce you a little bit, and then you're going to be free for sharing your presentation. Based in Spain and shuttling between India and the Netherlands, Angad is an architect who specializes in computational design and digital fabrication. He holds a PhD with honors in architecture from UIC Barcelona, Spain. He works as a research associate in the Institute of Biodigital Architecture and Genetics. Angad also teaches computational design and digital fabrication as an associate professor at the Biodigital Architecture Master, and he also teaches in several architectural and design institutes in India as visiting faculty member. The scene is yours. Please enjoy.
Thank you so much, Alberto. Just sharing the screen. Yes, hello, hola, namaste. I'm Angad, and I'm here to talk a little bit about our current research and the one that we presented in the conference. It's called Computational Ecosystems. And here I'm going to talk about architecting design automation algorithms for additive manufacturing using cellular automata. I'll be focusing mostly on the relevance of computational ecosystems in the now. At the same time, we'll be briefly scratching the surface of the theory a little bit, and then talking about the implementation that we had using additive manufacturing. So breaking the topic down into these three parts and talking about the relevance, the theory, and the implementation. So yeah, in the relevance, I'll be talking about the historical significance of this entire topic and the research relevance that goes behind it. The theory would talk a little bit about the theoretical framework and the semantic syntax that goes behind sort of architecting these computational ecosystems and what they basically are, and how cellular automata plays a role in them. And in terms of the implementation, I'll be talking about the procedural sequences and some empirical insights that we had at the end of the research. I'm going to talk a little bit about the connection that's happening now in terms of the built form and the design, and what happens with the introduction of the fourth industrial revolution. So we had some primitive built forms, and there was a primitive idea of design, and then there was a primitive representation of built forms with design centuries ago, and then the treatises that brought the relationship between the built form and design together. And then with the industrial revolutions, this relationship started developing a little bit more, and then around the third industrial revolution, we came with a solid integration of the built form and the design. The built form meaning whatever is built, and the design as in the representation of it, the documentation of the built form. But now with the introduction of the fourth industrial revolution, there is a new player in this entire relationship, and it's the algorithm. The algorithm that helps the built form and the design at the same time, in the idea of its documentation, in the idea of its representation, and the idea of the construction of this entire built form. Well, taking this relationship ahead, what's happening now is we have this segmented idea of analysis, modeling, fabrication, with the idea of the structure, the material, the production. But then with the introduction of the algorithm, the kind of profession of architecture has sort of bifurcated into these two roles. The role of a delivery architect who relies on software that is closer to BIM and is enhancing the construction process, while on the other hand, the design architect benefits from the algorithm in the sense of representation of the design. And that sort of makes the, emphasizes the idea of the allography of architecture, meaning designing by yourself, but then getting constructed from someone else, a contractor basically. But that's not all. Algorithm has also brought in key aspects into the entire AC industry that are completely supported by computational design and digital fabrication. And they're helping the algorithm and the built form at the same time. And this is actually helping the architect to become autographic again, meaning someone who designs and builds at the same time. I mean, prototypes, makes little fabrication models, and then sort of brings an intervention in the entire architectural process. But apart from this, there's also the intervention of AI, the seminal book that Professor Yomna was just talking about, AI to Matter Reality. We have seen how these diffusion models have added another aspect in the whole relationship between the built form and the design. Does this mean that design in this day and age would face the fate of becoming a little bit obsolete? Now, what would happen in this case, and how do we project this? Following up on this idea, we generate a hypothesis that says, as computational design becomes more autonomous, the role of design as just a mediator of the construction project might become redundant. While digital fabrication becomes more data-driven, generating construction documents might also become redundant. If I have a robot that is constructing my design, why would I face the necessity of generating plans and sections and elevations? And at the same time, if I have data at my behest, and if I'm designing with all this data, why would I require a mediator in the entire construction project? So taking up on these ideas and trying to understand what happens to this new role of design, let's say that we don't remove design in this whole new rethinking of architecture, but at the same time, what we replace it with is a communicational logic, a logic that says that we have a built form that is constructed, monitored, and governed by an algorithm. But at the same time, the built form constructs, monitors, and governs the algorithm. So it enters this kind of a loop, recursive loop that sort of generates this entire process. Now, do we have these kinds of computational models that have already done this? Well, cellular automata is a topic in computational sciences which has been developed for many years, and then it sort of had its own, let's say, cellular automata winter, yeah, it can resurface in this way to have this communicational logic that has a built form and an algorithm at the same time. So considering these ideas and considering that the built form and the algorithm would have the cellular automata and the G code in the form of a language that machines use to communicate with each other for construction parts and such. Let's say this is the communicational logic. This is the computational ecosystem that we are trying to develop. To take this further, the research focused on theorizing it, taxonomizing different kinds of simulation models, and prototyping using different fabrication methods. But the idea was to break this down in terms of the theory and to understand what the key players are. So there was a lot of research, a lot of theoretical understanding done in fields of computational, fields of ecology, set theory, programming, game theory, and the study of UMLs to actually convert this into a language. But trying to understand this, the whole idea of cellular automata, and to take it down into a computational ecosystem, there is a lot of research that's been done in ecology that says that a computational ecosystem could be inhabited by a species, and those species are sort of controlled by a community dynamic. This is the same logic that's used in cellular automata, which says a neighborhood is populated by some cells, and the cells have a relationship of cell states between them. So to convert this logic into our language, we say that the ecosystem is inhabited by some elements, and which follow some rules of economies. So elements, economies, and ecosystems. I will start with some examples just to break this logic down a little bit more. Say that the elements are just kinds of players of this entire world, like the chess pieces. The economies would be the moves that these chess pieces are allowed to take, the kind of rules that govern them. But the ecosystem is the entire game that they play, the kind of different gambits that they have, the different kinds of strategies that they develop. Well, of course, this idea had to be completely symbolized, that there would be an element and an economy, and they would be inhabited inside an ecosystem. But this also gave the idea that there could be permutations and combinations of the cardinality of the elements and the economy. So there could be a single element and a single economy, but then at the same time, that entire interpolation could go and follow Flint's taxonomy and go on to become a multi-element and multi-economy ecosystem. So considering this idea of going from a single element, single economy up to a multi-element, multi-economy ecosystem, we went on to develop some cases, of course. And this is the example of a canonical single element, single economy ecosystem. The elements in this case are just dumb cubes, hexahedrons to be more sophisticated, and these are controlled by the idea, the economy of being of having structural support for each other. So it's just a stacking exercise to stack cubes on top of each other. But the simplest form would be to stack a cube on another cube and go on, so on and so forth. But here we would have a structure that would be overstructured, and we don't want that. So we go for something that is optimized. So on the left, you see a UML diagram that talks about the entire rule that goes on. And in the middle, you see a simulation using Rhino and Grasshopper, of course. So we start with an initial state. There are two cases. There are two different initial states. and that triggers the algorithm. It sort of makes a first kind of level of how it would grow in that particular direction. Now, again, this is following cellular automata, the rules that were generated using cellular automata. And the rules, again, were pertaining to the fact that this is structural stability by only considering axial loads. It would allow some cantilevers, but then that's what the ecosystem sort of comes up with on its own. So yeah, these are two different states, two different initial conditions, and let's see how far they go when the algorithm sort of runs. So as you can see, although they start with the same number of elements at the base, 10 to be precise, one goes on for around 6 levels, while the other goes on for 29 levels. And this is the sort of variation that we see. This sort of gave us an idea that, yes, of course, it's not just a dumb rule that's sort of, setting this up and having different variations of different forms, but it's also the idea that if we start with a slightly different organization at the base, considering the same amount of elements, we could get varied amounts of volumes, varied heights, a sort of its own biodiversity, in spite of starting with the same kind of system. We then started applying this in by using additive manufacturing, and we took up a case where, let's say, in this case, that we don't have elements that are just cubes. We would have elements that are planes, and we would try to construct a kind of a built form. We were taking up the case of a clay sort of extrusion machine, which was mounted on a KUKA. And this was part of a sort of a research study that I did with a research stay, that I did with Studio Rap in Rotterdam. So the idea there was, okay, fine, we are using a KUKA robot to actually build something using clay. But a robot does not understand points, it understands planes. So the planes became the elements for this particular ecosystem. While the economy of the ecosystem was governed by two different aspects. One was the trunk of this particular form. We thought of making a monolithic coffee table, something small that could take up some volume, the kind of volume that we could print, that we could extrude. So we took up a trunk and a top that would be separate pieces of this particular coffee table, but then they would be constructed together. So we went ahead and put it in our recipe of having in this case, it was a single element multi-economy ecosystem, because there were two rules, one for the top, one for the trunk. Of course, if this was the coffee table, the volume that we could print was just 10 kilos. So we had to flip it the other way around, because the top had to be supported and we couldn't go for infill or supports inside the coffee table. So the logical, sensible thing was to flip it around. These were the initial planes that were cast onto the table, the volume that could be printed in an optimized form, and it generated kind of this variation that was structurally viable to do. Well, yes, of course, we ended up printing it, and then it was also taken up for glazing in the specialized Delft Blue system. But yeah, here are some videos that sort of illustrate that entire process. I would just quickly run through them, and this is the final sort of outcome that we generated. So yeah, the idea was to start with a system that could be as a communication logic that would work between the build form and the algorithm. And in this case, design is something that we don't draw up in a sense. That is given off to a contractor in the entire allographic sense of architecture. But then here we are actually using it as a communication logic between the build form and the algorithm. And we are actually generating these prototypes, these build forms by ourselves. So yeah, that was the entire idea, and that was the architecture of computational ecosystem. I think my presentation is going to be followed by Pablo and Femi. So good luck, guys. And thank you so much for your patience.
Thank you, Angad, for your fascinating presentation. And yes, you're right. Our next two presenters are Efimia Giannonopoulou and Pablo Vaquero, both doctors. Yeah, I'm going to introduce you a little bit with your bios, and then the scene is going to be yours. Efimia is a research-based licensed architect, founder of Fabrelium Studio, born in Greece. She graduated from the School of Architecture Faculty of Engineering of the Aristotle University of Thessaloniki. And also she completed her master's in biodigital architecture and PhD and International University of Catalonia in Barcelona, Spain. She has participated and organized more than 20 exhibitions and has been a co-teacher of international workshops in DigitalFUTURES, IGRADI, ICADI conferences, among others. She's a member of the research group and office of genetics architectures and has been a collaborating professor of the International Masters in Biodigital Architecture within the Institute of Biodigital Architecture and Genetics, IBAG UIC Barcelona. She has currently joined XJTLU in China. Pablo, on the other hand, is a computational architect, artist, designer with an interest in natural systems and computer simulations. Founder of Research Fabrelium Studio, born in Colombia, he has lived in New York and between Barcelona and Greece. He has a PhD in genetics architecture from UIC and Barcelona and a Master of Science in Advanced Architectural Design in Columbia University in New York. He studied American architecture at Cooper Union and performing arts at New York University and has a Bachelor of Architecture from UPC in Bogota. He has been co-teacher at TU Delft Hyperbodies with Nimich Bailoria and has taught at the Biodigital Masters and USC Barcelona with Afonso Orsichu and Carl Schu, Matias de Campo, and independently also. In addition, he could teach at the Pratt Institute with Peter Macapia and Parsons University with Andrew McNair, and has been invited to participate in final reviews as a jury critic and GSAP, Columbia University, Pratt and Parsons. Okay, he has been joined also to Saudi Arabia with Professor Helmut Portman, and currently he teaches at XJTLU in China too. Okay, the scene is yours. Please start and enjoy. You are mute, by the way.
Yes. Hello, everybody.
Now it's working, yeah.
Thank you for the invitation. We are going to present today the article, the BIODIG Conference 2023. Form force pattern-driven mechanisms, workflows using AI for fabrication applications for architecture. This presentation is going to include also some a recap of all the latest works that we have done since 2020. So the idea behind this is that we are looking for inspiration on biological patterns as a mechanism for pre-rationalization design methods. So in order to do this, we are using some simulation and segmentation strategies, and with the use of machine learning. And we have done many different prototypes. So in order to investigate the structural properties of this type of biological patterns, we were looking a lot in reaction diffusion mechanism and using, of course, design softwares from architecture. But after many trials, we find out that this is a very complicated task. So we try to look at the new tools of machine learning that can offer for deciding how would be the most optimal, or at least the better decision for this. This, of course, is a kind of crossing disciplines, and sometimes we have to collaborate with some people from computational biology. And in general, the idea is the methodology behind this is that the idea is that we want to see how to uncover the behavior of the system. And for this, we need to identify some key factors that they are behind it, which, according to Dante, refers to extending our design intuition. So the model, the neural network, is tested to predict simulation results, and in this way we can save some time. But it's more important as a method to provide this possibility of interpreting those data and help us for a better decision. So the framework is examining the generative design workflow, which integrates the structural form finding, manufacturing techniques, material properties, tolerances and constraints, machine limitations, and interactivity inside the unified system in equilibrium. Furthermore, this is integrated inside the machine learning approach in order to generate data sets, and with this the neural network is trained. We can have some results of that we can, let's say the hypothesis was that from the form force dependence of a minimal surface, we can have the form force pattern dependence for fabrication application, which is the title of this article. So, Pablo?
No, just wanted to mention that also inside this journey that we have been working about the force-driven pattern of using the mechanisms of nature and part of the techniques of computation and fabrication to use for architecture. We also been teaching some workshops about morphogenesis, biological patterns, and fabrication. And also DigitalFUTURES have been helping us on how to do this. For example, in 2020, 21, 22, we have done 4 or 5 workshops throughout these studios, and in order to organize this information. We have also one in 2020 that it was oriented about how using these databases and how to customize the databases and organize information in order to teach the computer, teach the machine to make a personalized information in databases. So for this, we use some workflows that generate an algorithms and specify different types of weights for the attributes and attributes and the different properties of the shell structures. And this is basically how we teach the nature, the computers, how nature behaves, and this is how we use the computers to do trial and errors learning like this is how we also optimize the methodology and workplace. For example, this is one of the workshops from 2022, in which there is some workflows that they are using inside structures and optimize the stripe segmentations for generating different typologies of projects. Also, 2022, last year, we had also some projects from other students that were experimenting with segmentations of meshes that are
Pablo,
oriented. Yes.
Pablo, excuse me, can you get closer to the mic? I'm not hearing you clearly. Thank you.
Okay, I'm getting closer. Now it's better.
Yes, please.
Okay, good. No, I was just mentioning that there is a few students that they were experimenting with different segmentation patterns for masks or pieces of the body, some other type of coral type topologies in these workshops that we're teaching in these workshops for DigitalFUTURES. And some other people were working on textiles and wearables for working on different type of strands on the meshes to generate different mesh topologies on the surfaces for the textiles. So these are just the work from students that have been working from the last 4 years in DigitalFUTURES. This is another one in 2020. Sorry, it doesn't play the video. But basically, yes, also you're working with the Lamila self-supporting structures. In which they are showing some there's some examples of the projects from the students. Yeah, basically this is the way that we have been working. So basically, most of the time, what we teach in this these workshops is the technique of generating big quantity of databases. So this is just an example of how the students were selecting an optimized method that is by using the attributes and the weights that the databases are making for this training later afterwards. So this is what I want to explain. Basically, this is some other outcomes of the workshops of the workshop that was in 2020. That's where it is. And basically, this is us. I don't know who is after this presentation. Thank you very much for your time.
Thank you very much for your presentation, guys. The next one is going to be Dr. Lamila Simisic. Yeah. Lamila, yes, she's there. Yeah. Lamila is interested in advanced digital applications in architecture practice and computation within the genetic processes of design. She finished her PhD and a master's degree at Universitat Internacional de Catalunya. Yeah. the work of investigation of her PhD thesis is about justified beauty. Architectural sensorium is about the justification of the beautiness by confronting architecture, art, philosophy, engineering, computation, biology, and ecology. Her research regarding the position is a combination of art, technology, philosophy, computation, and architecture. She's trying to find a niche in between disciplines that do not necessarily belong to one disciplinary field, but belong elsewhere. Lamila is interested in the visualization of data and the design of spaces that combines art, technology, and architecture. She is also exploring new possibilities in architectural design by searching for possible visual languages that are reshaping visual compositions and architectural elements such as align, shape, color, solids, and voids, and their compositions into more intuitive languages, much like character-based language. How could data that is produced, transmit, and received shape the space? Her interest is in the usage and visualization of data collected on our journey throughout virtual and real realms, and as element for the construction of the overlapping realm. And she looks for the identification, humanization, and beautification of the artificial and the real, fostered by a new dialogue between humans and both realities. Lamila, are you there? Yeah, ready?
Yes, I'm here. If you can just turn on my camera because I'm somehow not allowed it.
Really? Oh.
Yeah.
As to start video, maybe? Okay.
Yes.
Now, just try it. Yeah.
Okay, I'm here.
Yeah.
Thank you.
Okay.
Thank you very much.
The scene is all yours.
Okay. Thank you, Alberto, for kind introduction, and thank you, Professor Estevez in Digital Future, for giving me opportunity to present my paper that I presented on a conference a few weeks ago, as it is already mentioned. So today I will present the research work under the title Architecture for Architecture, that is exploring the potential of the archive data for architecture creation and how archive data and artificial intelligence affect the future of our shaped environment. This research, as already been mentioned, looks for the realities identification, humanization, and beautification, and it is an attempt to understand architecture as neither a representation or a critical review, description, or the concept, but architecture for architecture. Is it possible? Why it's possible? And is it paradoxical, or if it's not? In order to bridge the traditional understanding of data collection, its investigation and archiving, this project explores the data procedure that understood with the contemporary technologies such as AI. And while we are learning about how AI is sorting and populating moments of our history in its mathematical matrix or the latent space, we might promote the collaboration between the existing and the possible, artificial and real, and the engagement of human-machine collaboration in the creative processes might amplify our creativity and imagination. Talking about the collection that I use for this project, since every decision-making process of the machine learning is based on some collection or their archive, for this research work, for the academical purposes, I use the project that never been built. So this is never built projects or never built architecture that have been donated or designed for the city reconstruction of the city of Sarajevo after the siege in the 90s of the last century. So the majority of the projects that you might see on the screen right now are used for the as a training data set, are from the catalog of the exhibition named Sarajevo Unbuilt Project for a Destroyed City, which took place in the Museum of Modern Art, Ljubljana in 1996, and later in the same year in National Gallery of Bosnia and Herzegovina, Sarajevo. Other projects are part of the study lab of Woods, also related to Sarajevo war and architecture, and some projects that have been designed for the public buildings, reconstruction or construction the public buildings in Sarajevo. As I said, none of these projects was never constructed or built in Sarajevo. So to train this model, I use the generative adversarial network, and particularly for this research, I use the most popular form of gun, style gun, as you may see on the screen. And as a brief introduction, GAN is built out of two components, generator and discriminator. The generator takes an input signal noise and generates images that discriminator needs to detect as a real or fakes. The involvement of AI in the process of discovering and expanding the potential of the archive data or the collection that I use for these research works enables an exploration of the space of the generated data set in its multidimensionality. So the process of digging through the multidimensionality of the latent space that was generated serves me to discover and expand the full potential of the data or generated images. So curating results of that processes or the images that have been generated from the trained model helps me to understand how AI finds the meaning out of the data sets trained on, considering multi-dimensions of image shape. So I begin from the random location in the latent space. I curated images of additional randomness by applying different truncation factor. And this provides the closer or further results from the most realistic samples of the trained model. These videos that you seeing on the screens are presenting the interpolation or the truncation of the different instances of the latent space. It is a result of the walks or the jumps into the latent space. I got more subtle or dramatic effects depending on the truncation values. The jumps into the latent space explore the voyage from one instance into another. Walking through the latent space shows the beautiful experience of what the model has learned from the data set and what it sees and represents as possible architecture. I also try to capture details of the trained latent space in the sample outcome, and experiencing the materiality through the morph of one image into another fades and reflects the complexity of the multidimensionality of latent space. The result is a liquid form, as you may see, continuously changing in the scale and shifting from darkness into the brightness. In this project, the neural network and decision were used to create alternative documents of our journeys through history and are the connection with the architecture of never built environment. In the end, I was happy to understand that the integration of AI into the creative processes of design enables the imagining the further possibilities of the archive data by exploring other dimensions of architecture besides only the physical one. And by giving the benefits to the outcome or outcomes generated from the collaboration of the digital and the physical parties promotes critical thinking of the existing and further develops our design intuition. By learning from the fraction of human history or of human knowledge via machine assistance, we've been bombarding our creative apparatus by impulses of the aesthetic discrimination, machine aesthetic discrimination, and the artificial database that was in the whole process created. We become taught of not just human creation, but also artificial one. So thank you very much. I think next comes Marcelo.
Yes, thank you, Lamila. Wonderful presentation.
Thank you.
Right, the next one is here according to the agenda. Marcelo Fraile. Marcelo, hi, welcome.
Hi.
I think I must, yeah, yes, thank you. I'm going to read your short bio and then you can continue, yeah? Okay, Dr. Marcelo Fraile is an architect, PhD in architecture, and a specialist in digital design and new technologies of University of Buenos Aires. And he has 25 years of experience in the project of the design sector. He has taught undergraduate, postgraduate, and doctoral courses at different national and international universities, including University of Buenos Aires, University of Costa Rica, the Complutense University of Madrid, the King Juan Carlos University, and the University of Oviedo. He has been project coordinator at Media Lab Prado Madrid, developing research related with the new digital technologies. He is also academic director of the master's degree in tools and technologies for the design of intelligent architectural spaces and UNIR, where he also teaches computational design tools. Also, he collaborates in the master's degree in multimedia design and production, and in where he teaches animation, and in the degree of digital graphics design, UNIR, and in the degree in interior design in the same university. He has experience in the use of new digital design technologies, and also he has received grants from the National University of Tucumán and the University of Buenos Aires on several occasions to carry out his doctoral and postdoctoral research. He was a civil servant in the Ministry of Culture of the government of the Autonomous City of Buenos Aires, and also author of numerous articles related to architectural criticism, new manufacturing technologies, and biodigital design. Welcome, Marcelo, and the scene is all yours.
Thank you. Thank you very much for the invitation. And now the presentation is, sorry, don't have the button. Lamila have.
Pablo, abajo.
No.
Screen.
No.
Screen? No.
No.
¿Qué sucede?
Now. Now.
Yeah.
Yeah. Okay.
You are
very,
but you must put it down. Perfect. Yeah, now it's working really well.
Okay. Thank you. Very quickly. I love these phrases because it's the idea, the evolution, no? The change, the modify the form, modify the structure. I think, and the Mr. Darwin too, everything evolved. The evolve in the natural, of course, in the technology, and the digital design world. The evolution is very important, and today is more relevant. And the idea of this project is point the evolution in the center of the myth, and joined two worlds, maybe different or maybe particular, the natural world and the technological world. The idea is create a beautiful morphology, but too efficient morphology. The project have 4 parts or 4 step, no? See the natural, create and model, evaluate to model, and finally create the building. In the first search the natural reference, I use the loofah because it's very interesting the form, and maybe the surface with the different fibra and 3 holes, and the longitudinal holes inside, no? And the next step was create 2 different models. The first model, very simple. They create 2 different curves,
but curve grade 2 and the facade plane. And the second model using the curve grade 3, and the surface is very undulate and more beautiful. No? With the two models, using the algorithmic genetic to modify the form in relationship with the radiation to create different form, but optimize the form. It's very, very interesting to see the different form and the modify in the space, the radiation, and the optimized form in the line, but the structure to change in the different points. The second model, more beautiful, the structure change because in the middle have a curve to change the model and create more surface to the facade and surface optimized to use inside. To see the different structure, because it's more chaotic, because the different parameter, and the radiation is in maybe a little more than the first model. The next step was use artificial intelligence to evaluate the data and try to understand the structure and understand the different distribution in the space, this data, and try to optimize the form. The idea was select the second model because it's the more interesting and potentially is more possible to change the form and create different element because the point middle the surface. The next step was create a screen around the surface to protect the surface the building, and use the genetic algorithmic to try the optimize the form again. The idea was create two different. In the first model, use the proposed and modular rhomboidal, and change the module, change in the top and the base. Change the more close in the top is more open in the base. And it's very, very important to create more protection in the top with the sun is more direct, and in the base is more open and permit is possible to see inside and outside. The second model is different because the skin is and metallic and close around, but have the cones is same the telescope and focalize the sea and create the ventilation in the different part of the building, and is more transparent the inside outside. Next was using the artificial intelligence, evaluate the data, and try try to understand the better form and create a new version to join the better element to the both form. The relationship, they modify and evaluate to three different structure: multiple-line regression, principal component, and clustering. The evaluation and produce a new model. The idea is this model reduce 42 less radiation in compare the model, the principal model, and is create more natural light inside of the space and need less energy to heat and cooling in different the years. And the better is increase in green space and 70% of the through the green in different floors. No, and the idea, the project is change. The idea that the project is less the box and change for the other building. In the 2010, the professor Francisco Jaurata say the evolution needs a new word and a new change in the architecture. He proposed the idea, the revolution. Now, with this project, I propose the idea that change this for this. Thank you very much.
Thank you very much, Marcelo, for your presentation. And now the next one is going to be David Torreblanca, but I'm going to support him because he's facing few issues with his voice. So what? Okay, firstly, your introduction, David. Yep. David Torreblanca is a Chilean product designer, master's degree in product design technologies. His research project emphasized biomimicry and biodigital design as a result of a transdisciplinary convergence between biology, design, parametric algorithms, and digital fabrication. Since 2002, experience in production design, teaching, research, and curriculum development. Has been international lecturer, workshop instructor, and as well part of the international exhibitions or in different instances. Associate professor at the University Pontificia Bolivariana, UPB in Medellin, Colombia. He's currently a communication director at SIGRADI and a PhD candidate in the Institute of Biodigital Architecture and Genetics and at the University International of Catalonia, UIC Barcelona, Spain. Okay, David is going to share his screen. Meanwhile, I'm going to present his presentation. Okay, just a full screen. Yeah, I'm going to keep my camera off, but they are because perfect. So biodigital architecture through 3D concrete 3D printing with a case of study. Yeah, introduction. Well, yeah, don't rush. Yeah, the previous one. Yeah, biodigital architecture is a fusion between biology and digital technologies, genetics and cybernetics, intelligence of nature and artificial intelligence, biolearning and machine learning, biomanufacturing and digital manufacturing, according to Estevez 2020. I3D concrete printing is an emerging technology with the potential to change practices in the architecture and construction industry. I3D-CP has advantages such as to build complex geometries without formwork, reducing time, cost, improve productivity, and in general, according to these references. The context, Colombia. Architecture, engineering, and construction, AIC in Colombia has had few in technical advances in the last decades and with low possibilities to integrate digital technologies, according to Chaparro. A research project. This project is the result of collaboration between universities and a company and public institutions among all together. Yeah. These are the institutions that were collaborating in this project. The goal is this one, to design architectural components based on nature throughout a synergy between digital algorithms and 3D concrete printing in the context of Medellin, Colombia. 3D printing, nature, and computational design, and the intersection is the biodigital proposal between I3DCP, computational design, and nature. In this presentation, the results of the first stage oriented to the design of columns will be shown. So firstly, from nature, the morphogenetical synthesis has been the second step, then morphological transformations as a third stage. And from there, the optimization throughout finite elements analysis. Then from that step to the selection of alternatives, 3D concrete printing and the detailed design in parallel. And finally, conclusions and improvement and as an iterative and cyclical process throughout the whole previous steps. So dimensions and proportion of tree trunks, well, were used as a reference in terms of height, ratios, diameters, and also for the roots, yeah, with these proportions. And also taking in consideration all these data that is coming from these different cross sections, yeah. Some tree studies in Medellin, Colombia, so as these trees were used as a reference for this research. Yep. So throughout this abstraction process from the real to the digital as a morphological synthesis, David developed these morphological transformations that you can see here from different angles. And from these were the select models for this finite elements analysis. So the compression test was tested using these parameters with wall thickness, materials, the force, mass, and efforts. So the results in terms of the digital simulations were these ones, in which you can see the differences between model 1, 2, and 3 in terms of pressure, yeah, and its best performance, and compression efforts, yeah, throughout this graph. So the select model, which the second one, in detailed design, in this case, including reinforcing structure of metal bars inside, with 2 options for the model 3 in parallel. And yes, this is a detail for the model 3 and how it was developed this. And then the 3D concrete printing. So this has been developed in the Innovation Center and the Constructora Concreto in Medellin, Colombia, with an example there at Origami. Yep, you can see the few examples. And the large format 3D concrete printing working there. So, yeah, so the large format 3D concrete printing was the machine that David used in this experiment, yeah, with the Superflat company. The technology that was used was a concrete extrusion system with a printing area of 6, 3, and 3 meters in total, yeah, with a nozzle diameter of 12.7 millimeters, 15, and 25.4, yeah. So the nozzle speed that was used for this experiment was 25.4 millimeters with a speed of 6,500 millimeters per minute, with a concrete mix developed by this company, yeah. with a layer height of 10 millimeters, with wall thickness of 35, and with a total printing time of 45 minutes. So the machine, it was the mix from that company, yeah. And then the attempts of this machine. So with a few, as I remember when these are all the cases that are not precisely successful, with testing the different materials. And then finally again, yeah, more images about the machine. And finally, one successful attempt there. What the column, well, I suffer an issue here. Give me a second. Yeah. Yeah, I'll return. Yeah. So the reinforcing structure of metal bars were placed inside the 3D print wall. Yeah. And then the comparative study with conventional techniques. Let's say all these molds that were developed in parallel, trying to compare which technologies are if a technology is better than the other one. Yeah. And the conclusions. The use of nature-based morphologies has been a contribution to the project in the 3-base column proposal. Had a superior structural performance compared to the geometries commonly used in the column design. Yep. Throughout the 3DCP, it was possible to materialize complex morphologies without form work, reducing time and cost, scopes that are not feasible with conventional concrete manufacturing techniques. About a 3DC process, a key factor is the concrete mixture, the mix, yeah, in balance with other variables such as a printing speed, nozzle diameter, ambient temperature, among others. The first stage of this research shows the advantage of a biodigital approach, a synergy between parametric design with additive manufacturing and models based on nature. And thank you very much. And well, now the contact details of David, and yeah, David is with us, even if he's sick now, but thank you for being here, David. And yeah, we just finished now, and now it's time for the round table with questions and answers. So please turn on your cameras, and we are going to start. Alberto, Lamila, Marcelo, Roberto, Pablo, yeah, Gustavo. I think we missed, someone is not here, maybe. Yeah, yeah. I think John is not here now. Okay, and who else? Yes, because I'm not sure if it's 2, 2, 3. Yeah, we're almost all. Okay, and my camera for sure. Yeah. So, well, this has been a super inspiring round of presentations with selected projects from this conference. And well, firstly, I want to give you a few words from Alberto for sure as organizer of this conference, but also please you could start with few questions for all the participants here, and then I'm going to continue with more questions that are coming from the social media and chat here internally. Yeah. So I'm not sure if you want to start, Alberto, with a few questions, or it's up to me too. Yeah.
Only to say thank you very much for taking in attention the conference. It was a great event, and yeah, I see that it continues with different branches. But okay, let's see if someone have questions too. Okay, yes. Thank you.
Perfect. I'm going to start with the first question coming from the chat. Yeah. Well, maybe this is a question that you could answer indeed. What was the initial inspiration of the program from the history of the program, Alberto? Yeah.
Okay, I have posted exactly today in Instagram and in Facebook a little idea from where this come. But at the end, the point is that when I was founding the school in '96, I began to invite all the pioneers of digital architecture or of the vanguard of architects, architecture, etc. So they was not connected each other, and they began to participate teaching in the school. So it was great to see that all these guys was not beginning his own lectures with Le Corbusier, Mies van der Rohe, blah, blah, but they was beginning, all of them, pioneers of digital architecture, they was beginning explaining things about nature, about biology. So this was very curious. And later in December '99 comes a big information ball in the news everywhere in the world, in radios, TVs, newspapers about genetics. And this makes me think in this moment that, genetics was applied in medicine, in agroalimentary, in food, etc., industry, etc., but not in architecture. So I was thinking, okay, why not in architecture? And this is what in January I found the research group Architectures, Genetic Architectures, and the master about biodigital architecture, to understanding that we can apply, we can research, we can teach, we can apply in our designs this fusion of biology and digital. Yeah, so it's 23 years ago that we began with this idea, and now I see that, well, more and more architects understand how important is biology to learn, and after applying digital tools to make reality the possibilities that nature teaches, no?
Yeah, so if in that sense, firstly, it started with a biological approach, and then the digital came as a complement, as supporting the research, or how that happened?
It's all together. All together. Yeah, because at the same time that I was inviting all the pioneers of digital architecture, as I have explained you, at the same time they are explaining the sources of nature. Of course, I am also from 83, 85, 86. I was specializing in Gaudí, and this was also an important background to understand that Gaudí is the first parametric architect in the world at the end, no, with his models that is defined by parameters and not by formalistic things, no. So all comes together in a kind of big fusion. Gaudí, Dalí also, because Dalí is understanding in Barcelona, in the works of Gaudí in Barcelona, how you can approach to architecture from surrealistic points of view. So, and this is why we teach the first days in the master all these things. So we go to visit the Gaudí works. We understand the sense that how Gaudí have of biolearning behind his works. We visit also the Dalí works, etc. And this is in a big, as I say, a fusion between biology, digital tools, and gives us this approach of biodigital architecture.
Perfect. So, well, now maybe it would be really interesting to expand this a little bit about how do you see the future of this research with the acceleration of technologies and science progress, as an example, AI tools and computation. Yeah. This is also for you and for all the participants here. Yes. How do you think that this is evolving?
Maybe someone can take the word and explain.
Exactly. Yes.
Lamila.
Yeah.
Okay, so how do I see the research with the acceleration of the technological and scientific progress? When I actually look for the master degree and I read about the biodigital master in Barcelona, I understood that I don't understand nothing out of that introduction. So I asked myself, how come someone who is trained architect, because I finished 5 years of my study before that, do not know anything about biodigital. So I've been kind of attracted by not understanding anything. So I never regret coming to Barcelona and joining the master, even though it was very hard, very, how to say, time consuming. So we literally lived in the building of where our master was given. So somehow we've been trained to always to search for the new possibilities and to involve the technology, especially the digital one, and to somehow make the mix between the bio and digital, between the biology and the digital, between the technology and the biology. So in all our, how to say, parts of that master, we learned that mixture is important, so that we cannot follow only one line, so that the how to say, the benefits and the kind of the results are coming from the mixture of from that collaboration between the bio and the digital. I don't know why, but somehow even when I look back to my life, I'm always somewhere in between. So I'm always in between to. No, even the architecture, they've been saying that it's in between. So it's not art, it's not engineering in totally. So I coming from the city, which is also in between the West and the East. So I study biodigital, which is in between. So somehow I'm finding that we shouldn't actually try to follow only one direction. So that acceleration of technological and scientific progress might always be in a mix with something else to reach the more, how to say, human results.
And now Pablo and Femi that have the Chinese experiences, yes. What happened so far from us?
Yes, we are investigating the Chinese conception of space here. And we have found that there is a very, very much connection with nature. But somehow this is not understood or applied yet in the architecture. So, but the philosophy behind the China philosophy is very much related to the nature. And
no, basically, I just wanted to mention about the question of speed that they were talking about here in the chat, and how quick the brain thinks in comparison of how computers actually process the information. And I quite think that there is a very good relationship of how the computers analyze nowadays with the artificial intelligence, the processes of conceiving space, and I don't have a doubt that there is going to be somehow machines actually generating new type of spaces. So the architecture nowadays will be enhanced by nature.
Maybe Angad could continue with some ideas about that.
Well, yeah, I think the question really about the future with all this explosion of what's happening around us. I think at the end of the day, it comes down to linguistics, to communication, and how you talk to the machine, how you talk to people around you, how you talk to nature in a way that you're actually trying to decode those secrets and convert them into the understanding of usability or functionality of actually building something. So yeah, I think it comes down to the inherent aspects of us being humans, of us being people, of being able to communicate. And yeah, I think the sooner we adapt to these technologies, the sooner we try to build with them, the more efficient, the more sustainable, the more fun it's going to be. So yeah, that's what I feel, and that's what we are trying to pursue day in, day out. I think yeah, when Lamila was saying that that you literally lived here during the master, I'm still here.
Yeah, I see.
Yeah, I'm still here, and so yeah, it sort of lives on with you, and the whole intensity of the program, the whole intensity of the research, yeah, it's just part of life then. Right?
Yeah.
Thank you for the opportunity.
Well, maybe I'm not sure if Marcelo or David could, or more of you want to add something more. Maybe David just by the chat. Marcelo, do you have some thoughts?
Okay. Yes. It's very strange this moment. I don't know. I teach undergrad and in the master, no, and in the grade, the student more young are very conservative. Very. You talk about the, I don't know, the biodigital architecture, I don't know, form, topology, and this is afraid. It's very complex. And I don't know, in the master, the idea is the form very strange, and the finish. The form. I'm no interest in the function, no interest, no import the, I don't know, the efficient energetic. I don't. It's strange because the idea with the high technology now is possible a lot of elements, but is more conservative and is same the box, no mix or join different theory. I don't know.
Yeah, well, it's quite interesting. Yeah, indeed. I want to continue this with something that is coming also from the chat that I want to highlight in a way. I'm not sure if you can see in a clear way the transition of all these ideas, all this research as a large framework to design and also the arts, and also let's say, how are you thinking about to create this a proper bridge between your scientific research and to the, let's say, the practice in the end, because when we must build a certain point if we are architects, yeah. So I'm not sure how are you visualizing this process, because you are experimenting a lot, yeah, from this let's say quite provocative perspective as a designer and also as a researcher. But let's think about how it's possible to translate that into the practice. What and how and what, and I don't know. It's up. I don't know. I'm just opening that question.
Yeah, I don't know. The artificial intelligence, they create the images, and One student the last week presented the Ville Savoie with the other colors. Okay, but is the more important the Ville Savoie today, and with a lot of technology, is strange.
Alberto, how are you visualizing this transition from the academia to the practice, maybe?
Well, I am also architect designer, and I don't see no gaps, no distance. I only see one problem. Client that wants that I build something. For me, it's not a problem. I say this at any time. Yesterday, we had a jury with the students again, and I was telling to them, all these towers, biodigital towers that they are designing, if someone say to you that it is a utopia, it cannot be built, etc., is only because they don't know nothing about construction and structures. But I say to them, sorry, I can do this. If someone say to me, Alberto, build this tower, I build tomorrow, I begin, no problem. I don't see problems in structure and construction for make reality our designs. I only see a problem of management, of find the client. And as you see also, you have seen also these spectacular buildings that are real, that are built, but only we need a generous mécène, a generous client, as Gaudí had. If Gaudí had not Condé, we have not Gaudí. So Condé understand how in front line is Gaudí, and he's behind. And this makes that now Barcelona is rich in tourism, in money, and everything. So we need generous, rich people that understand that what we are doing is very, very important, also for the planet.
You're completely right. Sometimes it's more about a cultural problem. You know, the persons that were actually they have their own biases about what exactly it should be architecture now. Sometimes they're thinking about these pristine, super clean and simple buildings instead of trying to be more creative with the new proposals. Yes. More ideas about that, or yeah, Pablo? Yeah.
I have an idea about the issue of actually constructing this type of new type of architecture. And from the professional perspective and from the materialistic perspective, there is always a small little gap of the behavior of the materials. That when you actually design something, and the computer has a totally different and also from the humanistic perspective, how the human is actually receiving this type of shapes. Because sometimes the shapes are beautiful, but I don't know if they will accept freely in these spaces.
Mm-hmm. Interesting. Yeah. Angad or Lamila? Lamila, Angad, no? More ideas about this?
Yeah, maybe we will push technology by our designs, like in the past.
Yeah.
Gaudí pushed the technology for design. So we will expand towards the metaverse as well. So in general, I don't think only the buildings is architecture. So it's much wider than only to build. What does it mean? Architecture. So we are somehow provoking or expanding our creativities, working on our creativity, and as we know, technology is also pushing us towards something which is not materialized. So materialized maybe in some different sense, as I said, towards some environments, virtual environment, immersive environments, which are also part of our civilization.
Yeah. I have few more questions coming from the chat. Yeah, from YouTube. So, well, I'm going to share with you these last questions. With the first one, with this research about nature informing design in the broad spectrum of disciplines throughout informatics, is our goal to assimilate the creation as an inherent relation or reaction to our environment? And if that's so, at what point does the difference of context between places and geographies can impact our way to respond? That's the first question. I'm not sure if this is clear enough.
Well, when I hear about context, I become crazy, because the conventional and traditional people speak about context when they are building a house in a city. But which is the context? The neighbor that is only 50 years old, or the tree that is millions of years old? So our real context is nature. Our real context are the trees, and not these silly houses that are around us.
Yeah. Pablo? You have the microphone now open. No? Marcelo? Nothing about context? Angad, because I have some one specific for Angad. Is the second question is coming here. Maybe let's move on to that one. Are we targeting our designs as a Star Trek replicator-like agency, or like a von Neumann self-replicating machine?
That's quite an interesting question, and yeah, I think Alberto, it's down your alley as well. I mean, yeah, we are because it falls in the spectrum of automaton and and such. But yes, I think in that aspect we have this this idea that's fantasized in science fiction and such. And we tend to sort of drift towards that direction. I don't know. Maybe that's going to be where the future gets pushed towards. But yes, I think there are lots of these aspects that sort of govern the design as well.
Yeah.
Sorry. What happened? I just saw people waving.
Yeah. So Alberto just
okay. It was
he was saying goodbye. Indeed, we are reaching the end of this. We are just reached the 2 hours of which is usually what we are actually using for this streaming. So now I'm just giving you the chance to give some final words from this experience, from each of you. So feel free to say something about this as a final words for each of you. Who wants to be the first one? Well, Alberto also just already say goodbye, So maybe Marcelo, Lamila.
Okay. Yesterday, I was told a very good story. You say the magnetic North Pole move 100 meters a day, approximately 40 kilometers a year. The explorers of the South Pole, I don't remember, wrote Amundsen, is in the South Pole. He said, I am moving away from. I still I am moving away from home. No, I suppose creo we need have the move. We need have the move again. Thank you.
Thank you for your kind words. Paula, Filia, or no? If you want to continue with your final words, or Angad or Lamila. Yes, it's up to you.
Yeah. Well, thank you so much for the opportunity, and yeah, it's been a privilege talking and sharing our ideas here. I think it's a very important aspect about research to have this dialogue from time to time. Yeah, whether it's course correction or it's just to understand where we stand. So yeah, I think it's been a privilege. Thank you so much.
Perfect. Lamila?
Yes, thank you once more, Alberto, for the invitation, and Digital Future for giving us time. And as Marcelo said, we need to move. I hope our future is very bright, so can't wait to see what is happening. Thank you.
Perfect. Thank you very much for your words. Pablo, Fimia?
Thank you very much, everybody, for the nice presentation. It was very nice to see that everybody nowadays is with these nice new ideas and very creative and inspiration. It's very nice to see this. Thank you very much.
Thank you, Pablo.
No, I just wanted to appreciate the time for all of you and DigitalFUTURES and Alberto Estevez for the presentation, for the opportunity to present here. And no, I just wanted to say that keep us nature, keep inspired. That's it.
Thank you. Well, and I'm sure if David is allowed to say something, because he actually wrote something. So I'm going to read it. Thanks for this invitation. It's a beautiful space to share creativity and experiences about design, architecture, and biodigital proposal. So thank you for your words, David, and plan to be okay soon. So from my side, I must say that thank you very much for all your time, because this has been something, always really time demanding, because we need to coordinate all the things, uploading things and then etc. Yeah, it's also something that we are actually love, because if without you we cannot do this. Yeah, so we are building this network of let's say connections among different actors that are actually pushing the boundaries of our discipline towards something more provocative, and more, let's say, in tune with what we must do as architects and researchers and designers. And so, well, in that sense, I would like to say also thank you to all the DigitalFUTURES team, because I think this is the last talk from this season, because we are going to jump to the workshops that are starting soon during the next week, and all the things that I want to introduce now. So I'm going to share my screen. Okay, give me a second. Yeah, presentation again. So share screen. Yes, so you can see it. Yeah. So yeah, this has been our last presentation of this first part of the year. Yeah, before the festival. So these were all the presenters that were participating in this last season. And what's next? Well, the DigitalFUTURES 2023 Festival, as I mentioned, yeah. From 24th of June till the 1st of July, hybrid workshops coming from different parts of the world, including China. From the 22nd to the 29th of July, online workshops are going to be happening from different parts of the world, in different languages, including Portuguese, Spanish, Turkish, English, Arabic, and Farsi. And also what we have in July 29 is the closing ceremony. So let's be in touch with this before show with YouTube and also Discord, and the guys that are going to be on Zoom participating in these workshops for sure. They are going to enjoy this experience. Also, there's an invitation for all the guys that are in touch currently with all of us from the Spanish language or also English and in the different ones for sure that are actually building this community. There are a few, well, you can access to YouTube and you can repeat, you can rewatch, or also you can follow all the different events that are actually happening almost 24/7. Yeah, are happening during different days, and just feel free to join us also, and just watch all the things that are in this huge repository of knowledge that are available for free. Trying to because we are democratizing the access of this digital education. Yeah. Also, in terms of the Spanish one, okay, we are what is actually happening. All the things that were happening are also there, and also in the different languages. And yeah, and finally, because we are also finishing this today, I want to say thank you very much for all your time. A huge hug to all of you, and seriously, we want to see what is going to happen with your research during the next year, because the things are evolving, and yeah, we are rapidly increasing the complexity of what exactly we are doing in a good way. So feel free to join us to our team if you want to collaborate in a deeper way, or just trying to be in touch if you have any ideas or things to do, because we want to collaborate. Thank you very much. And this has been our presentation today. Thank you, thank you, thank you. Hugs and good luck to all of you.